Welcome back to BIO-CHEM Academy. Today we are treating first principle. We are treating first principle. Let's say, and when we treated general rules of differentiation, we say y. Let's say y. If y is equal to what? X raised power 2. You can say change in what? In rate. You can say change in rate of y or change of y in respect to x is what? Dy over what? Dx, which is equal to what? Bring down the what? Power 2, then multiply and what? Subtract 1 from the what? From the power, which also give us what? 2x. But when it comes to first principle, you add you add y to what? Change of y, then x. You add what? X to what? Change of x. I come again. When it comes to what? Using what? First principle, you add what? Y to change of y, and what? X to what? Change of x. In this case, you can say y plus what? Dy is equal to what? S plus what? Dx bracket what? 2 raised power 2. We are solving this particular question using what? First principle. So you can say y plus what? Dy is equal to what? Seeing a square, bracket raised power square, s plus dx raised power square. It shows that what? This is what? 2. That is, let assume you are given 2 square. It still same thing as what? 2 times 2. 2 square is 4. 2 times 2 is what? 4. So here we can say our y plus dy is equal to what? X plus what? Dx bracket what? X plus dx. Then y plus what? Dy is equal to, now we now use what? We will now use every value in this bracket to multiply every value in this bracket. I come again. We use what? Every value, each value rather, in this bracket to multiply what? Every value or each value of this what? Of this bracket. Which is, you can say x times s is what? S square plus x times ds is what? S dx. So dx times x is what? Plus what? X dx. So you can say ds times ds is what? Plus what? Ds square. So you can say y plus dy is equal to, in this case, then in this case we have to what? Cross our x over here, or let's say our s square plus what? S ds plus ds. S ds plus ds is what? 2s dx plus ds square. So getting to this point, then we have to what? Y plus what? Dy will be equal to what? Getting to this point, we have to what? Cross our what? Y over here. So if you have to carry our this y to this place, it becomes what? Minus. So now our y, our x will be, it will now become s square plus what? 2s dx plus 2s dx plus what? Plus dx square minus y. I'm sorry, become y. Since y is crossed over here, so it remain what? Dy here. So now we can say our dy will be equal to what? S square. In this case, getting to this point, we know that our minus our y is what? Is x square. But we can say but y is what? Is n square. So now we can say our dy is equal to s square plus 2s dx plus what? The s square minus what? S square. We have already replaced it with what? S square. So now our dy will be equal to what? Here, in this case, we have plus x here, we have minus x square here. We have plus s square here, we have minus s square here. So x square, we cancel s square. So in this case, we can say what? 2s dx plus what? S square. So now we can say our dy is equal to what? In this case, we have to what? Divide both sides by what? By dx. So now we now be equal to what? 2s dx plus what? S. This has been cancelled. I'm really sorry. Be what? This will be dx square. So now it now become what? Dx square. Since we are dividing both sides by dx, this will be what? Dx, and this is what? Dx. So now this will cancel this. This will what? Will also what? Cancel this. This is 2dx. It remains what? 1. We know that this is dx. Dx square is what? Is ds times what? Dx. We know that ds square is what? Is dx times what? Dx. So now this first this one will cancel what? The first one, and it will remain what? 1 what? Dx. Then you can now say our dy, we are dividing both sides by dy and dx. This one is we are dividing both sides by dx. So you can say our dy over what? Over dx is equal to what? 2x plus what? Plus dx. So now getting to this point, we can say we have to what? Limit our ds to what? To 0. We have to what? Limit our ds to 0. That is, wherever you see ds, put what? 0, or replace it with what? 0. That's what first principle is all about. So get this point. Since you left with what? With dx, then you have to what? Limit your ds to 0. That is, wherever you see ds, you have to what? Put 0. So in this case, you can say our dx, dy over dx is equal to what? 2x plus what? Plus 0. Then we can now say what? Our final answer, which is what? Our dy over what? Over dx can now be what? What? It is equal to what? 2x. So using what? Using first principle to solve these particular questions, we still what? Arrive at what? At the same answer rather. So now here, using the general method is what? 2x. Using what? First principle also what? Arrive what? At 2x. When it comes to what? First principle, you get to a point that you have to what? Limit the x to what? To 0. Let's solve let's take another question, another example. Given that y is equal to x raised to power 3, then in this case, using first principle, our y plus what? Plus dy is equal to what? I said it earlier that you have to what? Add what? Your change in y to y, and add what? What? Your change in x to x, plus what? Plus dx. Here we now say our y plus what? Dy is equal to what? X plus what? Plus dx raised to power what? 3. So in this case, you cannot say our what? Our y plus what? Dy is equal to, in this case, we are using what? Binomial expansion. So we are using what? Binomial what? Expansion formula. So using the which 6 binomial expansion formula 6 a plus what? B raised to power 3 is equal to what? A raised to power what? 3 plus 3a square b plus what? 3ab square plus b raised to power 2 raised to power 3. So now apply this what? This principle, we can now say by applying this what? This formula of what? Of binomial is what? We can say y plus what? Plus dy is equal to what? What? Here should be what? S raised to power 3 plus what? Plus dx plus x plus what? 3s what? Dx raised to power 2 plus what? 3s dx raised to power what? 2 plus what? Plus what? Dx raised to power 3. So now you cannot say our y plus what? Dy is equal to, in this case, in this place, we need to what? Cross y over there. So when over here, so when y is crossed over here, then our y will become what? Minus. So we can say x raised to power 3 plus what? 3s raised to power 2 plus 3s raised to power 2 dx plus 3x dx raised to power 2 plus what? Dx raised to power 3 plus what? Minus y. Not plus, should be minus y. So now we can say our what? Our dy is equal to what? Since x, we can say but y is what? X raised to power 3. So our dy will be what? X raised to power 3 plus 3x raised to power 2 dx plus what? 3x dx raised to power 2 plus what? Dx raised to power 3 minus what? S raised to power 3. So now we can say our dy will be equal to what? In this case, we have to what? Divide both sides by what? By x, by dx rather. So our x raised to power 3 plus 3x raised to power 2 dx plus 3x dx raised to power 2 plus dx raised to power 3 minus x raised to power 3. Get to this place, before we divide it by DSF, we have to what? This we have s plus 3, s raised to power 3, and we have what? Minus s raised to what? Power 3. So this we cancel what? This. Because we have this is positive and this is negative. So in getting to this place, then we can now say what? Our dy is equal to what? 3s raised to power 2 dx plus what? 3s raised to power dx raised to power 2 plus what? dx raised to power 3. So getting to this point, we have to what? Divide both sides by what? By dx. So now we can say our dx we what? We cancel what? ds here. So the same ds we also what? Cancel what? We have 2 dx. We have what? 2 ds here. So it will cancel 1. It what? It will remain 1. So now we can say our dy over dx will be equal to what? 3x raised to power 2 plus 3x 3s dx plus what? Dx raised to power 3. So now in this case we can now say our what? In this case we have to what? Limit our ds to 0. We have to what? Limit. So to limit our ds, we have to limit our ds to 0. So now we can say our dy over ds is equal to what? That is, to limit your ds to 0 means what? Wherever you see what? X, put what? 0, or replace it what? With 0. So now in this case we can now say 3x squared plus what? Plus 3x bracket 0 plus we have what? Bracket what? 0 cube. So now our dy over dx will be equal to what? Here we have what? 3s squared. 3s times 0 is what? 0 plus what? 0 raised to power 3 is what? 0. So our dy over dx will always be equal to what? 3 what? X raised to power 2. So this is what called what? Derivative. So now our final answer here is what? 3x squared. So now using what? First what? Principle. Once you use the general principle too, once you use the general rules too, general rules will also end up with what? With this particular derivative. With this particular what? Answer, you got the same derivative using what? Using general principle to general rules to solve it. So now let's take another example. Given that y is equal to what? X. Let's differentiate this question using what? Using first principle. Then we can say our what? Our y plus what? Plus dy is equal to what? X plus what? Plus dx. So we can say our y plus what? We can say our y plus dy is equal to what? S plus what? Let me write it this way. So now ds. So now we can say y In this case, we have to what? Move y to this place, Abby. To this place. We can now say y, dy is equal to what? X plus x dx minus y. So now, get to this place where our y is what? Is x. We can now say our y, where our y is x, then we can say our what? Our dy is equal to what? X plus dx minus s. So now we can say in this case we have to what? X we cancel minus x, this we cancel this. So now we can now say what? In this case we are now say what? Our dy is equal to what? Dx. So get this particular point, we have to what? Divide both sides by what? By ds, which becomes what? Dx over what? Dx. So this cancel this will give us what? 1. So we can say our what? Our dy what? We can say our dy what? Ds is what? Is equal to 1. Please like and subscribe and comment for more videos.